Okay, quick recap of differentiation. Yesterday, basically, we covered only how to differentiate, and our next topic would be the applications. One thing was you're given with the equation y is equals to something. Differentiation first step is dy by dx, whatever it would be, and that will be your gradient or rate. And second step is d square y over dx square, which will tell you the nature of the point. For example, let me consider this: y is equals to 2x square plus 3. This is the equation, and the examiner demands that find the turning point. And we know whatever the turning point is, at the turning point the gradient is always 0. So what we do is dy by dx is equals to power multiplied with this number is 4x plus 0. Differentiation of constant is 0. So dy by dx is equals to 4x, first thing. Now we know gradient is always equal to 0 at the turning point. So when we substitute it with 0, we get the value of x as 0. Now we know the value of x, put it back and find the value of y. So y is equals to 2 into 0 square plus 3. So we know that turning point is 0 comma 3, first thing. Second thing, if we ask you what is the nature of the point, for the nature of the point we need d square y over dx square. So dy by dx was 4x and double derivative would be 4. Now how do we know if it is maximum or minimum point? When d square y over dx square is greater than 0, that is positive. So if it is positive, it is always a smiley face. If d square y over dx square is less than 0, which is negative, will be a sad face. So our case, it is positive, which will be a smiley face, and so we say it is a minimum point. I'll explain it again with one more example. Pi is equals to 2x cube plus 3x. Or minus 3x. So for example, we have this equation 2x cube minus 3x, and we have to find the turning point, and we have to tell either the turning point is maximum or minimum. So for turning point, we know that dy by dx will be equal to 0. That is first step. And for the nature, that if it is maximum or it is minimum, will be t square y over dx square. So when it is maximum, it is basically negative. When it is minimum, d square y over dx square is less than 0. Sorry, more than 0. Positive. Positive is smiley face. So first step, dy by dx is equals to 6x square minus 3. Now at the turning point, the gradient would be 0. So 0 is equals to 6x squares minus 3. Now we solve for x. 3 is equals to 6x square is equals to 1 by 2, and x is equals to plus minus square root 1 by 2. We know the value of x. We can substitute in the main equation to find the value of y. So y is equals to 2 into square root 1 by 2 cube minus 3 into square root 1 by 2. This will be the value of y. 2 into square root 0.5 cubed. Something's gone wrong. 2 into square root of 0.5, and that's cubed, minus 3 into square root of 0.5, and it is negative square root 2. So we know first point is 1 by square root 2 is x and minus square root 2 is y. This is the turning point. This is one of the turning point. Second turning point would be y is equals to 2 at negative x by 2. So negative 1 by 2 cube minus 3 into negative 1 by square root 2. So we put a negative sign here and we put a negative sign here, and this is positive square root 2. So now we have two turning points. One turning point is already there, and the second is when we have negative 1 by square root 2 as x. This is positive square root 2. So first step is you have this equation. One thing, we differentiate it. After differentiating, we substitute it with 0. Why we substitute it with 0? Because at turning point the gradient is 0. So at that point we solve for x and we have these two values. Put it back in the main equation, you get the turning points. So this is turning point 1 and this is turning point 2. Now we have to tell if the nature is minimum or maximum. So I'm copying dy by dx again. Dy by dx is equals to 6x square minus 3. Now double derivative will tell you if it is minimum or maximum. So dx square, this becomes 12x. To check, we need to substitute the value of x. So for first point, when it is 12 into 1 by square root 2, now we are not concerned with the value, we are only concerned if it is positive or negative. So this is positive. Positive means a smiley face. Smiley face means it is a minimum point. So I will say that 1 by square root 2 comma minus square root 2 is a minimum point. And on the other hand, we know that that would be maximum, but for the sake of working, we have to show this step. Is negative 12 by square root 2. Again, we are not concerned whatever the value is, but it is negative. Negative means a sad face. Sad face is maximum. So we'll say d square y over dx square is less than 0. So it is maximum at negative 1 by 2 square root comma positive 2. If I can show you, make it clear with this diagram. If you have one cubic graph like this, this is one of the turning point A, this is another turning point B. So what we are actually doing, what we were doing, we had the equation, we went for dy by dx and we substituted it to 0. Why we did 0? This is horizontal line. At the turning point, the tangent is always horizontal. That is why gradient is equals to 0. Gradient is equal to 0. And there we found two values of x, one of which was this, the other is at b. You can substitute these same values in y to get the coordinates of turning point. And third step is d square y over dx square. Greater than 0, positive. Positive people always smile and smiley faces, giving you minimum point. And if it is d square y over dx square less than 0, that is negative. Negative is sad, and that gives you a maximum point. Is it clear? Okay, sure. If you have this curve, step 1 equation, step 2 dy by dx is equal to 0. To find x, step 3 We substitute this x back to get the coordinates. So we have x comma y now. So this is our turning point. Then if the question demands the nature, so d square y over dx square is double derivative, and double derivative, if it is greater than 0, that is positive. Positive is smiley face, that is minimum, and the other way around is maximum. Let me copy some examples from your book. For example, we have this question: 4x square minus 8x plus 3. Four x square minus 8x plus 3. This is y is equals to something. And what we need to do is find the turning point and nature of point. These two things. 1, 2. Find the turning point and nature. Before we solve, we know this is a quadratic equation and there will be only one turning point, either this or this. Okay. If it would have been cubic, we know it would have two turning points. If it is quadrupled, we can expect three turning points. So in our case, in this case, it is quadratic. We'll have one turning point, either this or this. So first step, turning point. What do we know about turning point? We know that gradient at turning point is 0. That is why we go for dy by dx. We find the derivative. This is 8x minus 8, and we get rid of the constant. Now at turning point, gradient is 0. So we substituted 0 is equals to 8x minus 8. 8 is equals to 8x. X is equals to 1. First thing, we needed a turning point. We know the x coordinate of turning point. So I can substitute x back in the main equation, which was y is equals to 4x square minus 8x plus 3 to find y. So 4 minus 8 plus 3 is minus 1. So now I know at turning point x is 1 and y is minus 1. So we're done with the first step. Second is find the nature of the point. Who tells us the nature of the point? Yes, Mohammed. Yes, you can do that, but you won't be able to do it for cubic equation. So these are the two alternates. If there is no restriction, yes, you can do that. Other than that, for the nature of the point, in this case, I'm going to solve it with differentiation, but I already know that the coefficient of x square is positive, and this would be a smiley face. So let's do it. Dy by dx, copying it from there. This is 8x minus 8. Now double derivative is d square y over dx square. The power is 1. 1 into 8 is 8. 1 minus 1 is 0. So we get rid of this x, and this is constant. This goes to 0. And there you go. Double derivative is 8, which is actually positive. So I can say d square y over dx square is greater than 0. So it is a minimum point. Got it? If we can sketch this, this would look like this, and the turning point will be x1 y minus 1, and There you go. Turning point is x1, y minus 1, and it is a smiley face. Mahad, clear? Yeah, Mahad. Okay. Now this question was demanding. What was this question demanding? It said find the gradient. So writing the derivative dy by dx is 8x minus 8. Find the gradient at point this. So x is 1 by 2. Just substitute x 1 by 2. And at x 1 by 2 the gradient is minus 4. So find the gradient is minus 4. Second part says find the coordinates of the point of the graph where the gradient is 8. So dy by dx is already 8x minus 8, and where the gradient is 8 is equals to 8x minus 8, 16, and x is equals to 2. We know x is 2 and we need to find the coordinates. So when x is 2, we put it in the main equation to find y. So y or f of 2 is equals to 4 2 squared minus 8 into 2 plus 3. So 2 times 4 times 16 minus 8 2 times 16 plus 3 is 3. So what are the coordinates when the gradient is 8 is 2 comma 3. C part says find the gradient y is equal to f of x at the points where the curve meets the line this. So first we'll have to solve for the point where it meets. May I say at that point y is actually equal to y. First it was 4x square minus 8x plus 3. Secondly, it is intersecting with the line 4x minus 5. So first we solve them simultaneously. I'm substituting this y here and it becomes 4x minus 5 is equals to 4x square minus 8x plus 3. Rearranging 4x square minus 8x minus 4x plus 3 plus 5 is equals to 0. 4x square minus 12x 5 6 7 8 equals to 0. We can divide all with 4. So x square minus 3x plus 2. Going for midterm breaking, x square minus 2x minus x plus 2, taking out common. So x minus 1 into x minus 2, and x is 1 and x is 2. So the question demanded find the gradient where this line meets the curve. So this line actually meets the curve at 2 points, which is x1 and x2. So gradient and in these 2 points would be copying dy by dx. From the first part it was 8x minus 8. So this is your dy by dx. And at 1 gradient is 0 and dy by dx at 2 is 8. 3 parts done. Getting it? Okay, look at question number 4. It says find the coordinates of point on the curve this where the gradient is 3. So this is the hint where gradient is 3. So let's find the gradient first. dy by dx is equals to 2x plus 5. Done. First part, gradient is given 3. 3 is equals to 2x plus 5. Solving for x. 3 minus 5 is minus 2 is equal to 2x and x is equals to minus 1. So now we know when the gradient is 3, x is negative 1, and the complete demand was to find the coordinates. We already know what x is. So we have the main equation. So y is equals to, substitute the value of x, 1 minus 5 minus 4 is minus 8. So our final answer is, when the gradient is 3, x is minus 1 and y is minus 8. Question 5. Find the gradient of the curve. We have to find the gradient for what case, when y is equals to x square minus 5x plus 10 at points A and B, where the curve meets the line y is equal to 4. So where it meets y is equal to 4. Question 5. Y is equals to x square minus 5x plus 10. So we have to find the gradient at A and B, and the condition is A and B at the point of intersection when y is equals to 4. So whatever this would be, sorry, yes, it is 2x minus 5. So the story is, you have this curve and you have this line y is equals to 4. It intersects at 2 points. This is A, this is B, and it is asking that find the gradient at point A and B. So first we find A and B. So it intersects at y is equal to 4, so I'm substituting 4. 4 is equals to x square minus 5x plus 10. Rearranging, x square minus 5x, 10 minus 4 is 6, is equals to 0. Midterm breaking, minus 2x plus minus 3x plus 6 equals 0. This is minus 3x. So x minus 2 minus 3 into x minus 2 is equals to 0. X minus 3, x minus 2, and we have two values, one is 3 and the other is 2. So this would be 2 comma something, and this is 3 comma something. We are actually not interested in y, we already know the value. Even if the value was missing, we were not interested, because the demand of question is to find the gradient at point A and at point B, and you just told me that dy by dx is 2x minus 5, and you see we do not need y for this. So x is 2 and 3. So 2 into 2 minus 5 is minus 1. So I can say gradient at A is equals to minus 1 and gradient at B is equals to, at B it is 3. So dy by dx again, when x is 3, 6 minus 5 is 1, that is 1. Minus 1 and 1. Question number 6. Find the gradients of the curve y is equals to 2x square at points C and D, where the curve meets the line this. So question 6, base story is y is equals to 2x square, y is equals to x plus 3. At the point where they meet, we need to find the gradient. So we need to find x. Firstly, it is 2x square is equals to x plus 3. Y is equals to y, substituted y and y. 2x square minus x minus 3 is equals to 0. 2x square minus 3x plus 2x minus 3 equals to 0. Midterm breaking. Taking out x common, we left with 2x minus 3 plus 1 common, 2x minus 3. So x plus 1, 2x minus 3. First is x is equal to minus 1 and the next is 3 by 2. So demand was to find the gradient at the points where they intersect. So they intersect at x minus 1 and 3 by 2. For gradient, dy by dx is equals to 2 into 2 into x, 4x. Y is equals to 2x square, gradient is 4x. So substitute 1 by 1. 4 into minus 1 is minus 4, and dy by dx on the other point is 4 into 3 by 2, that is 6. Getting it? The values will change. The nature of question will stays the same. These values are changing. Nature of question is same. Yes. I just tried to show the working. I brought this power down, multiplied it with the constant. So 2 into 2 is 4, is equals to x. Y is equals, yeah. Okay, we can do it directly as well, like 4x directly without showing the working. Okay. What do we have here? Sketch the graph of y is equal to f of x. Okay, on the same set of x's, sketch the graph of f dash x. Explain why the x coordinate of the turning point of f of x is the same as the x coordinate of the point where the graph this crosses the x-axis. Okay, first let us draw, then we'll discuss this. X square minus 2x minus 8. Do you remember the chapter sketching? So if I have to sketch this, I know this is quadratic. I need to find the turning point, and I can also go for like midterm breaking to see where it intersects the x-axis or y-axis. So this is my y-axis, this is my x-axis. I'm going for f dash x. I find that easier and quicker. So 2x minus 2, and it is 0 at the turning point. So 2 is equals to 2x, x is equals to 1. I know that it intersects, it gives the turning point at x is equals to 1. And when x is 1, I'm substituting it in the main equation and checking that 1 square minus 2 into 1 minus 8. I know that this is minus 9. When x is 1, y is minus 9. So this is my turning point. Without going into double derivative, I know that the coefficient of x square is positive, so it will be a smiley face. What was the requirement? Sketch the graph of y is equal to f of x. Okay. So this is x1, y minus 9. We can solve for these point of intersections. Once x is 0, when x is 0, y is minus 8. You can see this directly. When x is 0, y is minus 8. So this point right here, y-intercept 0 comma minus 8, and for the other 2 points, x square minus 2x minus 8 is equals to 0. Let's solve for this. 4 2 times is 8, minus 4x plus 2x minus 8, x minus 4 plus 2 x minus 4, and x plus 2 times x minus 4. One is x minus 2, the other is x plus 4. So this is x4 and this is x minus 2. Second part says, on the same set of x's, sketch the graph of f dash x. Now this is f of x. Bring this down. F of x is equals to x square minus 2x minus 8. So f dash x would be 2x minus 2. Now I am sketching 2x minus 2. I know the gradient. but I'm going for this conventional method, like substituting few points when x is 0, when x is 1, when x is 2. 2 are also enough, but we are sketching, so I would need more. When I substitute 0 in this f dash x, I get minus 2. When we substitute 1, I get 0. When I substitute 2, I get 2. 2 times 4 minus 2 is 2. So let's use this black color that's missing. When x is 0, y is minus 2. X is 0, y minus 2. Let's suppose it is here. x1, y0. This is the point. x2, y2. And at x4, 4 2 times 8 minus 2 is 6. 4, this would be 6. And at x minus 2, minus 2 into 2 is minus 4, minus 6. Minus 6. So this is our sketch. We drew the sketch of both these on the same set of x's. Sketch the graph of f of x and f dash x. Explain why the x coordinate of the turning point of y is equal to f of x is the same as the x coordinate of the point where the graph f of x crosses the x-axis. Okay, why is this point same? This point. To summarize, f of x is equals to the equation, and we know when f of x is 1, it is minus 9, and it is saying that f dash x at 1 crosses 0, and why? Anyone, can you answer this question? Can you answer this question? Okay, what's the question? Question says the turning point of f of x, which we know is 1 comma minus 9. It says these two sketches, this is f of x and this straight line is f dash x, and it says these highlighted in yellow. It says why is it same? Why is the x part same? Why is it x1? And why is it crossing at x1? So the answer is, we know that the turning point is 1 comma minus 9, right? Are you with me on this? That the turning point is 1 comma minus 9. What is actually the gradient at the turning point of anything? Not this question in particular, 0. The gradient is 0 at the turning point. So what is f dash x actually? F of x is the equation. So f dash x is gradient. So when f of x is the turning point, f dash x is the gradient, and at turning point the gradient would be 0. We are substituting x1 in gradient, and we know that at turning point the gradient will be 0. So that is actually which is reflected here. At x1 it is 0. That is why it is equal. Clear? Okay, differentiating two or more terms is just separated with this positive negative sign. Let's try this one. If I multiply them, they become x cube minus x square plus 2x. Now I can differentiate them. These are three terms. So 3x square minus 2x plus 2. Done. Every other thing will stay same. Only the equation will change. dy by dx, nature is same. d square y over dx square, nature is same. The requirement of question is same. Find the gradient. Find the gradient. So looking at this word, we know we have to do dy by dx of the curve with the equation, the given equation at point A, where point A is given. for example, this is for this first question, we have to find the gradient for this equation at 0, 0. Question number 5 says f of x is equals to x into x plus 1, that is x square plus x. First thing, we need to find the gradient when x is 0. So f dash x is equals to 2x plus 1. So when x is 0, the gradient is 1. First part done. Look at this B part. B part says f of x is equals to 2x minus 6 over x square. The demand is to find the gradient when x is 3. Find the gradient when x is 3. So first I'm simplifying this equation for myself. F of x over x square minus 6 over x square. So when I simplify, this is 2 over x minus 6 over x square. I'm further simplifying and bringing this x in numerator, writing it as 2x minus 1 minus 6x minus 2. So this is f of x. Now I'm going to solve for f dash x, which is derivative. So multiplying this power minus 2x and we subtract 1 from the power. Now minus 2 into minus 6 is plus 12 and we subtract 1 from the power. Simplifying it again, minus 2 over x square plus 12 over x cube. Done with the differentiation part, we have to find the gradient when x is 3. So when x is 3, f dash is minus 2 over 3 square plus 12 over 3 cube. Remaining is calculator's job. Getting it? You only need to know how to differentiate. Any doubts till now? Okay. Gradients, tangents and normals, relationship between them, and then definitely practice questions. So let's consider this curve and this blue line and then this green line at this black point. So I will say I have a curve, quadratic curve, anything ax square plus b, anything x squared. In red it is x square. At a given point find the gradient. So gradient is dy by dx, and then it says at this given point find the gradient of the normal. So this is normal. And what is the relationship between normal and gradient? That is basically tangent. Tangent and gradient, they are perpendicular to each other. So m1 multiplied by m2 is equals to minus 1. This is tangent times normal is equal to minus 1. And tangent is dy by dx into m2 is equals to minus 1. So example, y is equals to 2x square plus 3. A quick sketch. So this is 0, 3. This is a quick sketch. It says find the gradient when x is equals to 3. When x is equals to 3. So we do dy by dx is equals to 4x. And when x is equals to 3, the gradient is 12. So at point x is equals to 3, if we draw a tangent, we know that dy by dx for this line when x is 3 is 12. Are you with me on this? And if the question will tell you that find the equation of normal when x is equal to 3. So we know when x is equal to 3, the gradient is 12. So when x is 3 and gradient is 12, the gradient of normal would be m1 into m2 is equal to -1. Tangent was 12. m2 is equals to -1. So gradient of normal is -1 by 12. Now I know the gradient for this normal. To find the equation, I need to find this point of intersection. And what was the x? X was 3. What will be y? Y will be y is equals to 2x square plus 3. Y will be 3 squared plus 3. 3 square is 9. 9 2 times 18. 18 plus 3 is 21. So it is 3 comma 21. Now we know everything we needed to know. Let me sketch it here again. At point, I'll repeat it. This was the curve. First thing, at x is equals to 3. At x is equals to 3. The tangent was this, and the gradient of the tangent was 12. Okay. For the normal looks like this, and the gradient of the normal is -1 by 12. Are we good till here? Now we have to find the equation of the normal. So for any equation, we need y equals mx plus c. We already know what the gradient is. First thing, for any point, this point was x3. So I need to find y. How would I get y? I'll substitute value of x in the main equation to get y. And y is 21. So for the equation, I know that the gradient is -1 by 12 and the given point is 3 comma 21. So y is equals to mx plus c. Y is 21, gradient is -1 by 12, x is 3 plus c, 3 1 times, 3 4 times. So 21 plus 1 by 4 is c. C is equals to 85, y is equals to -1 by 12x plus 85 by 4. A relationship between tangent and normal. Given curve, you do dy by dx at the given point, dy by dx, or you say gradient, or you say tangent is this thing. This is the equation of curve. This is the tangent. This is the normal, which is m2, and relationship between m1 and m2 is this. So this is the short story: tangent, normal, curve. And then practice. Nature of the question will be same, values will differ. Nature of the question will be same. You see this diagram, you do dy by dx, put the value of x, you will get tangent at a. For normal, m1 into m2 is equals to -1. 12f says find the equation of tangent. Okay, so dy by dx is 2x minus 7 at x2. When you substitute 2, this is 2 times 4 minus 7 is 3 minus 3. Gradient is -3. Now I already know the gradient and I know the point, so I can say y is equals to mx plus c. We know the gradient, we know the point, so consider this equation as done. For normal, find the equation of normal. There's one extra step. Dy by dx is 2x minus 5 at x6. So when you substitute 6, 2 6 times is 12, 12 minus 5 is 7. Gradient is 7. What about the normal? m1 into m2 is equals to minus 1. 7 into m2 is equals to minus 1. So m2 is minus 1 by 7. So no issue. We have the gradient of normal. Find the equation of normal. We have the gradient. We have the point. We have both of the things. Y equals mx plus c. So this is how you will do it.